There are tons of topics in this week's material that we could use some programming practice on. I think what I'm going to do is start by asking for some practice questions about iterators on vectors and lists. So we know already that we can apply iterators to any of the standard collections, so sets and maps and things. But it seems like it makes more sense to just ask it for iterator exercises, in a sense, separately, and then interesting, hopefully, exercises on sets and maps and other data structures. So I'm going to start off by saying I'm learning C++ via C++20. I just learned about iterators, which are neat. I only know the only collection types I know about are vectors and lists. Can you generate 3 programming exercises to help me practice with iterators? I sort of want a starter code exercise, but I feel like if I don't ask it a general question, I'm going to be constraining it too much. I may refine my request if these seem unreasonable. So, okay, exercise 1, vector iteration. Create a vector of integers and initialize it with some values. Okay. Use an iterator to traverse the vector and print out each. No, I'm not doing this. This is boring. We've done this a million times by now. List operations. Create a list of strings and initialize it. Use an iterator to find and print the length of the longest string in the list. So this is basically use an iterator to write a for each loop. And I'm not really excited about this either. Step 3, though, I think I can see how step 3 is sort of interesting. Okay, so then number 4, use a reverse iterator. Well, okay, I can do that. I think reverse iterators are sort of hokey, but okay. Exercise 3, map iteration. Okay, but I said lists and vectors only. Okay, what I'm going to do is I'm going to ask it. I like exercise 2, like the whole exercise 2. I feel like some of the parts of it are a waste of my time. Like writing this isn't good review because just writing initialization code is just going to take up time. What I'm going to do is I'm going to say, that's a good start. But maybe I should be more specific. Please generate 3 exercises involving iterators where the only standard collections used are vector and list, not set, map, or the unordered versions of set and map, or any other standard collections, but we'll see if it comes up with something. Let's see. Please, I'm going to ask it for starter code. I'm going to give it a pretty broad mandate, though. Please generate starter code for each exercise. And then, obviously, oh, whoops. I was going to say don't show me the solution, but I pressed enter. So we'll hope that it doesn't. Okay, so it seems to have stuck with exercise 1, the vector iteration one, which is fine. I'm just going to ignore it because also it gave me the answer. Oh, it's going to do that for all of them. Okay. Please generate starter code with parts missing for me to implement. Don't show me the solution. We'll scroll way down. Oh, no, it's okay. For vector iteration, it gives me almost all of the solution. I'm not going to do this exercise anyway because it seems like it's trivial. Exercise 2, list operations. Okay, this is what I was hoping for because I wanted it to create a list for me. I love this list. This is a list of fruit, and it even includes some fruit. It's got some fruits I wouldn't put in there normally. This is a great list. Okay, vectors. Okay, exercise 3 is new. Vector of custom objects. Okay, we've got our book type. There's one of these. This is a constructor. I'm going to find a way of deleting this when we actually do the exercise. And then there's main, and it's gotten stuck. Okay, well, whatever. I guess I can start on exercise 1 while it finishes typing, or exercise 2. Okay, exercise 2, list operations. Head back over here. I'm going to replace all of my code with the code that it generated. And okay, what we have is we create a list called words, which contains, I'm going to get rid of this equal sign because I don't like it, apple, banana, cherry, date, and elderberry. Well, now I often make lists of fruit, but usually I don't include cherry, date, or elderberry. I don't even consider, I never think of date when I think of fruit. Okay, this is good. I'm broadening my horizons. Okay, find and print the length of the longest string in the list using iterators. Well, I expect this is the longest string, and I have to use iterators. Maybe this is a good exercise just to get things started. So this is where I insert my code, your code here. Okay, I'm going to create an iterator object. Auto iter is words.begin. Begin. I'm going to keep going as long as iter is not equal to words.end, and at each step I'm going to do iter plus plus. It would be interesting, I don't think I'm going to do it in this video, but if you ask ChatGPT to give you some examples of iterator code, especially if you don't say C++ 20, it would be very interesting to see what it comes up with. Because we've noticed already, I've mentioned in the lectures, there are a lot of bad habits that people get into working with iterators that date back to ancient C++, and it's interesting how many of them persist, not because people are still being taught bad habits, but because they're looking at other people's code with those bad habits in it. It would be interesting to see how much of those bad habits ChatGPT has picked up somehow. Okay, so I'm just going to, basically what I'm doing is just looking at each, I'm looking at all of my strings and figuring out what the maximum length is. Now, I guess I could start by saying, well, okay, so if star iter dot length is greater than max length, then I guess my max length is the length of that. So max length equals star iter dot length. Now, the reason this exercise is sort of hokey, so one reason why this is a good exercise to do on iterator day, but not really a good way to do this exercise in general, is what we're doing here is looking at every element of the array, of the list. We could just use a for each loop, and we should, because a for each loop is way less unpleasant looking than this, but whatever. Okay, so we have this. I think I can run the code just as it is, so I'm going to do that. All right, it's upset about cited. Oh, yeah, okay. I'm going to, this starter code isn't a formal specification, so it made this mistake in the last video as well. When we're talking about links, we should use unsigned types, and the compiler wants us to, so I'm going to. Okay, practice iterators 1. It says the length of the longest string is 10, which does make sense, so it does match up. I'm not going to do much more detailed testing here because we know how to find the maximum element of a list. Like we know the logic for finding the maximum. This is mostly a demonstration of syntax. A couple of other notes about this. So one of them is that you've seen here how when I want to retrieve the element that an iterator refers to, I've written star iter. And in general, that's how we get that element of the list. But I could also, as a convenience, just like you may recall from C, if I don't want to keep writing star iter dot inside with brackets, like that's quite a lot of stuff to write, I'm allowed to use the arrow operator. Arrow length is the same as writing star iter in brackets dot length. So I'm going to try that out. And we can see that that works as well. And which one to use is basically a matter of personal taste. Okay, so if I wanted to do more detailed testing, I might do something like move around where the longest word is, but I'm reasonably confident we've written this loop or something very similar to it over and over again in this series of videos. The other thing, though, that I will observe is I am usually pretty pedantic about assuming that the maximum is a certain value. So I usually like to write something more along the lines of assume that the maximum length is the length of the first word, because that way we don't run into a problem where I'm like, oh, the maximum is 0, and then it turns out everything in the vector or the list is negative. Obviously, that's not going to happen here. So in this case, because it's a length and lengths can't be less than 0, I know that the maximum length is going to be greater than or equal to 0. The case that I have to be a little bit concerned about is where the list is empty. If the list is empty, there is a question of, do I want to claim the maximum length is 0, or do I want to claim that it doesn't exist? But in this case, I could just say, well, in that case, the maximum length starts off at -1. So if it comes out at -1, that means that the list was empty. So that's something that does cross my mind, but isn't as big of an issue when I'm working with lengths, which are definitely unsigned. Speaking of unsigned, wait a minute, I can't say this is -1. I'm not allowed to use -1 in an unsigned variable. So okay, there goes that solution. So I'll just set it to 0 and say if it comes out 0, that means that either the list is empty or every element of it is an empty string. So if I cared about distinguishing between those, I'll need a bit of extra logic. Okay, so that's the first little bit of the exercise done. Remove strings with length less than 4 from the list using iterators. And you know, I'm going to change this because there aren't any strings of length less than 4. I'm going to do less than 6 because there are 2 strings with length less than 6. And I want to remove them from the list using iterators. Now, this is, when I saw this one flash by as ChatGPT generated, I was sort of happy to see it because this is an exercise that allows us to get at a pretty thorny issue involving iterators, which is that in general, when you are working with an iterator, when you're looping over a sequence, if you modify the sequence while you're looping over it, you might have to start looping, you might have to actually start iterating over it again. So for something like a vector, there's this concept of iterator invalidation, which is if you have an iterator to something and you modify the structure of the sequence, the iterator might become invalid. For a vector, if you modify anything in a vector, you run the risk of all of the iterators you have for that vector becoming invalid. So there are a bunch of different ways of doing this. The way I would suggest to do an exercise like this, if it weren't specifically an iterator exercise, is just make a new list with all the words you want to keep and then copy them back into the old list. So I'll mock that up. So this is a sort of solution for a non-iterator version of the exercise. So here's a solution for the non-iterator version. If it doesn't say you have to use iterators, it's pretty much implying that I have to walk through the list and delete stuff as I find it, which is dangerous. It's a bit error prone to do it. Here's what I would do otherwise. I would just make a new list. So new words. And then I would just loop over, so for auto s in words, I would just loop over all the things in the old array, and then I would just add them if they're the right length. So if s.length is greater than or equal to 6, then new words dot pushback s. And then I just write words equals new words. That's it. I just take this new list and I just dump it into my old list. And then from the point of view of anybody observing from outside, as of line 28, I've achieved the desired effect. I'll do the next exercise just to prove that, because the next exercise involves printing. So this says, use a reverse iterator to print the remaining strings in reverse order. If you watch the videos or look at the notes or talk to me or come to the lectures, which hopefully you do at least one of in this course, you'll know that I don't like reverse iterators. I find them to be hokey. I've used that word like 10 times in this video. I guess I find a lot of iterator stuff to be hokey in modern C++. Reverse iterators exist and they can be useful sometimes, but a lot of times it just feels like there's something about them that doesn't, it just feels a bit off, at least to me. So I'll try using them. So I'm going to say auto iter, and it's going to be words.rbegin. So the thing about reverse iterators is they're a special kind of iterator. They have their own ecosystem of functions that you call, and you have to make sure that when you work with them, you don't accidentally mix them up with regular iterators. So I'm going to say iter is words.rbegin, while iter is not equal to words.rend, iter plus. And then I just print everything out. So I guess I'll do cout gets star iter and then a space. Yeah, that should be fine. And then I'll print a new line. All right, we'll take a look at that. So the idea was I excluded all the words of length less than 6. That would be apple and date. And I did it this way. This is a solution to an exercise that isn't specifically you have to use iterators to do it. But this is a solution that I think is a safer choice, especially on an exam where you don't have as much debugging ability, where you can just trace. But that isn't what they were asking for, so I won't do that. Instead, I'm going to try this. And I think this is a good way of demonstrating why this is so dangerous. Like why, if you do this, you do run into a lot of trouble. So I'm going to try doing it the most obvious way, and then we'll see what happens. So I'm expecting this to fail. And if it doesn't fail, I might have to fiddle around until it does, because it should. It should be, there should be cases where this doesn't work. Basically what I'm going to do is, so to delete something directly from a sequence, I want to use this function, words.remove. And you can see, I think it says that in there. It just says doesn't say use dot remove, but basically the dot remove function deletes dot erase. The dot erase function deletes the element referred to by a particular iterator. And actually I can demonstrate that. Let's do a quick demonstration of that just outside of the context of this. So if I write words.remove, I'm going to print out the words vector. Oh no, it's fine. It's printing in reverse, but it is still being printed. Words.erase, words.begin. So the first word is apple. So if I do words.erase, words.begin, and we'll try that, then you can see it deleted the word apple. Of course, the list is reversed, so apple should be at the end, but it's been deleted. I'm going to, if I use .remove, does that do something? I'm trying to remember, why do I think the function is called .remove? Yeah, it doesn't exist. There's a function in the library called .remove that does something slightly different, that removes a range of values, and I guess I've used .remove in some other language recently. I don't know. Okay, so it's .erase. That's what takes an iterator and deletes the element of that position. So what I could try doing, I'm just going to make sure this compiles again. What I could try doing is I could say, how about this? I look at the contents of this iterator. So I say if iter arrow length is less than 6? Well, then in that case, I want to remove whatever's at that location. So that's going to be, let's do words.erase iter. So I just delete whatever's there. And we'll see what happens. The compiler shouldn't notice, but it might result in some kind of trouble. And you can see it resulted in trouble of the worst kind. So we're used to standard library features maybe having trouble. Like, that is, we could use them incorrectly. If we use vectors incorrectly, we notice an exception gets thrown. If we call a standard library function with a bad input, an exception gets thrown. We generally don't see the standard library segfaulting, so the program crashing, unless we've done something really, really bad. Because the standard library is resilient, it's full of code to throw exceptions if errors occur. It's intended to be robust against errors. So here's what basically happened. std_list is a linked list. It's a doubly linked list, as far as I can tell. I think there's a separate data structure for a singly linked list. So it's a linked list where it's a sequence of elements, each one connected to the next element and the previous element. And when you have an iterator, what you really have, if you think back to CSC 111, is equivalent sort of to a pointer to one of those elements. And the pointer is pointing to a specific node of my list. The issue is, if I call .erase with a particular iterator, what I'm saying is destroy this node. But then, at the end of the for loop, I do iter ++. I take this iterator pointing to an invalid location and say move it forward. But I can't do that because the location doesn't refer to anything that makes any sense. It's an invalid location. It's a node that's just been destroyed. So you can see, if I erase as I go through the sequence, I can get myself into a lot of trouble. Okay, so how do I work around that? Well, as I said, my solution, frankly, is just make a new list. I mean, there are other options, but make a new list. Like you can see, this is a pretty clean solution. What I could do is, first, I'm going to turn this into a while loop, because that way it's easier to take it apart. The issue is the interaction between this .erase and this iter ++. Those two things are fighting with each other. If I delete the iterator before I increment it, then I can't increment it. So I'm going to make this a while loop. I'm just going to extract the components of my while loop here. Move that over. And then this is going to be while iter is not equal to words.end, and then I'll have this. So here's the iter ++. So this would still work as a for loop. I just feel like it's easier to point at each individual component of it if I have a while loop. We'll try this out. We'll make sure that it still compiles. It's still going to crash because it's exactly the same as the for loop I just had. Here's the problem. When I feed it this iterator, I'm going to destroy the iterator, and therefore if I try incrementing it, it's not going to make any sense. It's going to try and increment nothing, and then the program will crash if I try and use the next iterator or anything else. So what I'm going to do is this. First, I'm going to observe that I need the iterator that I'm using to keep track of where I am to be kept safe. So what I'm going to do is say, okay, if I have an iterator that points at this element, whether I want to delete the element or not, I need to make sure that when I'm done, I've got an iterator pointing at the next thing. So I want to keep clear of this element. So here's basically what I'm going to do. I'm going to make a copy of, I'm going to call it iter copy, I guess, of my iterator. I'm going to make a second iterator, and it's going to keep a position. It's going to keep track of the actual current node, and then I'm going to increment my current iterator right up front. And so the iterator I'm actually working with already points at the next element, and you can see that now I am free to destroy the element I was already working with. So I'm going to say, instead of using the original iterator, I'm going to use my copy of the iterator to interrogate the node and to interrogate the length and then erase if needed. And then I'm going to get rid of this iter ++. We'll see if that works. Okay, we can see it does. So elderberry, cherry, banana. Now this is something I should probably do a little bit more testing of. So I've deleted the first element. Let's add some more. Let's put them in alphabetical order. I think that's tasteful. So we'll do lemon and raspberry. And so we've got lemon should get deleted, and then raspberry shouldn't. Okay, that looks good. Now what happens if the thing I'm deleting is the last element? That's certainly a case. Because of my logic where I've got an iterator to the current element and I get an iterator to the next element right off the bat, well, what if there is no next element? I want to make sure that works. There's reason to believe that should work. I mean, either now or after a little bit of debugging, because we are allowed to walk forwards in a sequence of things using iterators, but I should make sure I test that. It looks like that did work. So I got rid of apple, date, and lemon. They were all of length less than 6, and I kept the 3 that were length 6 or greater. So this is one way to solve it. I'll leave it as an exercise to you if you want to think about how you could solve this using the for loop that we were already doing. So I have a while loop here, and the reason I like using a while loop is because I can then put the incrementation sort of in the middle of the loop body. I do the incrementation first and then tie up some loose ends before I wrap around to the next iteration. See if you can find a way of using the original for loop I was using, but making the code still work, so not needing to decompress it into a while loop. Now, that said, that's mostly an exercise just to build some dexterity. There's no reason you should have to use a for loop ever. You can use a while loop whenever you want. If the code works, then we're good. Okay, I think I'm therefore actually done this exercise, and this was a nice iterator exercise after all. So I've now finished the exercise involving lists. I'm going to head back over to ChatGPT. That exercise was detailed enough, and I don't think I'm going to ask for a replacement for the first exercise that was trivial. I think exercise 2 was long enough, assuming exercise 3 is also somehow useful. I'm going to stare at exercise 3 and decide what I want to ask it to correct. So there's a couple of things here that we don't want to know about yet. So it says class book. Well, what's that word mean? What's this word mean? And what the hell is this thing? So we don't know that yet. We're going to see it next week, but we don't know it yet. So I want it to get rid of that. I then want to try and figure out what it's asking me to do. Okay, so this is interesting. Okay, I got a couple of other comments about the way it's written the starter code. Can you rewrite exercise 3 to use only basic structures containing only data and no functions, just for added clarity, and no constructors. A constructor is a type of function, but maybe it doesn't know that. Let's see. Only basic structures. Yeah, let's see if that works. I hope it doesn't give me the solution. Okay, it looks like it's done exactly what I want. Okay, so here, this looks a little bit more familiar to us. I'm going to copy this. I'm going to head over to, I'll just use this file here. I'll paste it in. I'm going to try compiling it. Okay, nothing happens. That shouldn't surprise me. So what do I have? I've got a vector of this type book. And here we are, ChatGPT has generated for me a bunch of real books. I've observed this in a few previous videos, in this course in 111, but when ChatGPT has to generate test data taken from actual stuff in society, ChatGPT has a very clear bias. So here we can see that when it generated 3 names of books, it has generated 3 names of books that were written in English, maybe 50 or 60 years ago, by authors that all seem to have a few things in common demographically, to put it lightly. I've learned, because you can, if you ask ChatGPT for clarifications, if you say, could you generate a list of books and ensure that the books are written by authors from a diverse variety of backgrounds, it is able to do so. So it's aware of lots of books written by authors that, aren't white people from the United States or the United Kingdom. It's aware of those, but for some reason it has a weird little bias built in where if you just ask it for books, those are the titles it generates. Now, there are people out there that study this aspect of AI, this rather scary aspect of AI, but that's not a topic for this course, although it's something that I think a lot about. So we'll live with these titles it came up with. To be clear, these are nice books. And actually, this one in particular, and To Kill a Mockingbird, but certainly reading 1984 is probably I think that's good reading for these days, for the times that we're in. So the actual task, though, the programming task, is to iterate through the vector and print out the details of each thing. I don't expect this to be a difficult exercise, but it's interesting to look at the code ChatGPT gave me. So notice that the loop it wrote isn't like the iterator loops I typically write. So I usually use the auto keyword to get around using the true type of an iterator. But this is the true type of an iterator over that object. The variable library is a vector of book, and the type of iterators over a vector of book, the name of the type is this. What this means basically, the colon means go inside of. So go inside of the standard library, grab me the thing called vector and make it of element type book. That's how I instantiate a vector. Now, go inside the vector of book and get me the iterator type. So I do colon iterator. This is one reason why the auto keyword is so great. Before the auto keyword, you had to remember this long, sort of unpleasant type. I'm going to rewrite this with auto. I'm also going to get rid of the C-style initialization because I don't like it. And then here, everything else looks pretty standard. It likes using plus before, but that's fine. Okay, so I'll write this. I guess I just want to print out title, author, and year. So I'm going to print them on separate lines. So I'll print out title, and then I print out, so this could be star it dot title, or it could be the arrow operator, it arrow title, arrow title. Okay, and then we'll copy and paste that. And we'll do author, and then that's author, and then we'll do year. And then I'm going to add one extra line just to make the output to sort of keep it from all being mashed together. We'll try running that. And there it is. Okay, so we've got Catcher in the Rye, To Kill a Mockingbird, and 1984. Okay, so there they are. I think I'm done the exercise. I don't think there's much more testing that I need here because everything else is pretty standard issue. Another note, you'll see here how I'm pushing into my library vector. I'm pushing book objects by just giving the initializer for the book object directly in the arguments to push back, which is a pretty sensible way of doing it. I think that's good. I'm wondering, do we want more exercises just about iterators? I don't think so. So I suspect that if I ask it in the next video for exercises about things like sets and maps, I'll probably have an occasion to use iterators in that as well. So I've gotten some practice just using iterators by themselves. I didn't get to use .insert anywhere, but there are other exercises posted where I did that. It's not my fault. ChatGPT gave me these exercises and I did them. So in the next video, we'll talk about things like maps and sets.